Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Welcome everybody to the Trailblazers podcast. Here we interview the brightest minds creating products for the AEC. Here today we have Mathias Höbinger. Hopefully I pronounced that right. He's the co-founder and CEO of ShapeDiver, with 7 years of experience in consultancy to architects and civil engineers, working on geometrically complex large-scale building projects. Mathias excels in the development of specialized software solutions for CAD systems. He is the co-founder and CEO, where he applies his passion for software development, applied math, and CAD. Mathias has 2 kids, is an officer in the Army Reserves, and used to be a competitive volleyball player. Mathias, do you want to say hi?
Hi, great to be here.
Well, by the way, what an impressive bio. Like, you have done a lot of things in your life. I feel ashamed of me now.
Come on.
And then we have Alexander Scheifner, CTO and co-founder at ShapeDiver, an applied mathematician and experienced system architect. Alex specializes in geometry, CAD, CAM, BIM, optimization, manufacturing technologies, electrical engineer, and architectural applications. Alex, as a CTO, applies his experience in enabling complex geometry building projects. Alex has 2 daughters, loves sports in nature, cooking, and listening to all kinds of music. You want to say hi, Alex?
Hi, everyone. Hi, Valentin.
Thanks for being here, guys. I know you're super busy running ShapeDiver, and I also impressed with your bios. And first of all, let's tell everybody, where are you located? You want to say a little bit about where are your offices and where are you located right now?
Sure. We're in Vienna, Austria. I'm born and raised here. Alex, born and partly raised, I think.
Yeah.
Typical Viennese. Yeah. And actually, like, when I'm not sure if we're going to get into our professional bios, but essentially, there's quite a bit of overlap, because Alex and I, we studied already together here at Technical University, and then spent most of our professional careers so far together in the city.
Interesting. But you studied together, and then the companies you work on were always related with the AEC, or how was your journey from the beginning?
Essentially, we studied both applied mathematics and ended up doing our thesis with the same professor. And then we were working for some years in the same consultancy company, which is kind of a spin-off of that university. And that consultancy company, it led naturally to the foundation of ShapeDiver at some point. So, and essentially, that was already at the intersection of applied mathematics and architecture. So we did already a lot of automation with Rhino mostly, not so much Grasshopper, but with Rhino, writing a large library of Rhino scripts to automate tasks for reform buildings. That was mostly about optimizing facades and things like that. So we did that for a couple of years together.
Yeah.
And then at some point we had this Grasshopper idea.
And how is it, like, because you have such a different background? I'm an architect, and for me, it's like everything is about shapes and beautiful stuff. And you study something as complex as being a mathematician. How was for you dealing with, I guess, professionals or architects or engineers? It was easier to communicate between the stuff we do every day and applied mathematics? Or how was that first experience for you guys?
Yeah, it was very interesting and also challenging, but motivating, I would say, because the reason we came into architecture was because the professor we did our thesis with was teaching the geometry for the architects on Vienna University of Technology, for many years. So at some point, you realize that there's a lot of optimization that can be done in architecture, especially when it comes to complex shapes of facades and so on. And that's how we got into it, essentially, and found our position to talk to architects and engineers about this. Yeah. And I think it's interesting because that was basically the peak of this free-form architecture. So there were lots of really famous buildings being built that were like completely cloud-shaped, essentially. And a lot of the work was running optimization on these shapes and on the facades that were built surrounding these shapes to make them buildable. So interestingly, we were kind of at the connection point between the architects who wanted to design the nicest possible shape, right, and that fits the environment, and then the engineers who had to actually come up with the solutions of how to make the thing stand up. And we were kind of trying to translate with our optimization between the language of the architect and the language of the engineer to make something the architect designs buildable and have the static attributes that were needed. Yeah, the engineers.
I'm not sure if I should ask if it was easier to work with architects or engineers.
No, actually, you also ended up working a lot with manufacturers, of course, and contractors. So we ended up not only working with architects, but also with contractors, help them win the jobs, right? Help them win the contracts to actually build something, right? And estimate what will be their cost to produce a certain facade and install it and so on. So I would say it's different challenges with different stakeholders, right? With architects, when we were working with architects, our job was to make sure that the design intent stays as true as possible. When we were working with contractors, we had to essentially seduce the architect to actually accept the rationalization of the facade that the contractor was proposing.
It's really like almost kind of a navigation between the two constraints and the two languages. So I think, I wouldn't say one of them was harder. It's really an interesting kind of job to jump in the middle and try to make the whole thing work.
I like the polite answer, but true. It's just not harder or easier. It's just different jobs and it's just that. And another thing that for me it's interesting. Like a couple of weeks ago, I interviewed Chris Diggins, who is a professional software developer that comes from the software development world and then worked at Autodesk. And we were discussing that a lot of architects nowadays, right? They start coding, or software or civil engineers or any type of engineer, they start getting into the software development world, right? And we were discussing that even when they do that, they never, or in most cases, they not reach to a point that they become a software developer, because you need to learn so much, right? You need to learn about software architecture and DevOps and QA and product ownership, and there is so much to learn that they just end up adding more tools to what they do, not becoming a software developer. Do you feel with applied mathematics is kind of the same thing, where a lot of architects nowadays are starting to do what you do on a more, I don't know, not profound level, like analyzing facades and applying mathematics into their works? How do you feel the difference between like an actual mathematician doing complex stuff to like young architects or engineers are trying to do applied mathematics to what they do?
Yeah. Good question. Yeah.
So
I would say, in general, when you start a career, right, what you learn in university is a lot of theory. Let's put it like this, depending on where you study, but actually finding what you need in the day-to-day job is a complete different story in the end, right? It's also the same for us coming from mathematics, because when we studied, what we apply very little of what we studied actually in our day-to-day jobs.
Nowadays. It was more in the consulting work, but now there's very little mathematics left, let's say.
Yeah. And of course, it helps. It helps to know the foundations and to always be able to rely on them and go back, right? But for example, we did not learn, of course, when studying, we did not learn about what you mentioned, DevOps, software development, details. This is not something that you learn when you study applied mathematics typically, right? And I think it's the same way with architects. Architects, that you have to study such a broad field in the end, right? And then you start to build up and use your tools when you start a career.
Yeah, but I think it's actually, and of course it makes a lot of sense, I think, for them to do it, but it kind of gets to a little bit into ShapeDiver, the motivation behind it, and what we do, especially in the architecture AEC space, because we're not only working in the AEC space, but in the AEC space, my feeling is that lots of engineers and architects, I mean, there's the geeks that really love what they do, but many of them actually do it out of necessity, right? The tools that they need for the workflows they want to work with, they're just not there. So they learn coding out of a necessity to build something that they really need for their work. And I hope that's something where we can contribute a little bit, because we take away some of what we do, tries to take some of that pain away, deal with the DevOps, deal with all the back-end stuff that's not really relevant for the individual task that these people face, and allow them to work with tools they really love, like Grasshopper, for example.
What I would like to add is that, and I'm really amazed on what people, what architects achieve just by jumping into coding nowadays. I mean, the starting area has become lower and is becoming lower all the time, right? Especially with tools like ChatGPT. Amazing, right? So the productivity that can be achieved there is really, really, really amazing. I always ask myself, just looking back at what I had to learn, what I learned across my career, how is it possible nowadays to just basically collect all that knowledge, right? I mean, for example, looking at things like web development or so, it's like it feels like a big wall.
Yeah, the bar, it's lower and lower. It was the NVIDIA CEO, I think he said like 2 weeks ago that like we used to tell our kids like you need to learn how to code, and now he was saying like you don't need to learn how to code anymore. You just need to learn how to manage product, or like, because coding is not going to be a problem anymore. So it's just interesting how fast things are changing. And you mentioned ChatGPT, but you're doing it too. You're helping lower that bar a lot at ShapeDiver as well. And that's also something that is really curious. Like when I started using Grasshopper like 10 years ago and Dynamo, I remember that actual software developers were kind of, I'm not going to say mean, but they were like purists in the sense of like, you're not coding. If you're doing no code or visual programming, you're not a developer. And at that time, I used to think that way. Like I'm just a really bad developer because I don't know how to use C# or Python. But over time, that has changed so much. Like the less code you use, the better. The easiest, the better. It doesn't matter what you use as long as you can do it fast and efficient. And I'm just curious on how you ended up with the decision of going with ShapeDiver and lowering the bar, not only for visual programming, but allowing visual programming to use it at scale and actually produce apps outside Rhino.
That's a fun story.
But what I find really funny about what you just said is that, I mean, essentially, I don't know how Alex think about it, but actually, especially myself, I find myself looking back 10 years, I was definitely in the camp that you just described, right? So Alex and I, we were doing like these really, really complex and long scripts in Rhino script. that were dealing with, tens of thousands of sub panels, optimizing them, defining all kinds of details. And we were kind of almost a little bit looking down at Grasshopper as this, little tool for people who have fun with geometry, but not serious. And it's really, to me, it's really ironic that a couple of years later, we were basically jumping ship completely and banking on Grasshopper. But yeah, the story, do you want to tell the origin story? Or
just go ahead.
All right. So we were still working in that company, and we were having lunch or dinner, with some guys from Vienna who were planning on building a platform to host 3D files for 3D printing. There's a couple of these platforms around, of course, nowadays, but there was a short phase where everyone was trying to do this. This was a new thing. 3D printers were just becoming mainstream. Yeah. And so the question was, where does the content for all this 3D printing come from, right? And all these platforms were coming up, and there were a couple of people in Vienna who wanted to build one of these. And because we were geometry experts, and I don't know exactly how they found us, but they called us up, and we had dinner together and discussed their project and how we might be able to help. And after or during the discussion, Alex and I basically had just this obvious idea. There was at the same time where we were like, okay, but if you host these 3D files and everyone has the printer at home and can basically print unique objects, wouldn't it be much more powerful if this geometry is not just a static object, but something that you can actually adjust to what you need? Because then you go to this platform, you adjust the thing to whatever you just need right now, and then print it. So it would be much more powerful if the thing is parametric.
Yeah.
And we both at the same time realized that we know how to do this, right? Because we've been automating Rhino for many years, so we knew how to use the Rhino SDK to just build a Grasshopper server. And basically, we then went to the office, and within 2 weeks, I think we had the first prototype.
So it was really this magic moment, essentially, where almost like with eye contact in that meeting, we were knowing, you have to put Grasshopper in the cloud.
Yeah. And so basically 3D printing is the idea that started it. But we went then pivoted in various different directions over the years since then.
Yeah. That's so cool and so organic, so natural that you did it in that way. It's cool. And how was, I'm just excited to hear the rest of the story. How was, you had your first prototype, right? And then how was the first client? Tell me a little bit about getting the first client, if you can. How was that experience?
Yeah. So it took us around a year, almost pretty much, to go from this first prototype to a real product. Because of course, it's not enough to just have this thing running. You need a website, a platform, you need to have user management and all of that stuff. We had to found a company, we had to get some funding. So overall, it took us around a year to get to viability of some kind of product. That happened in early 2017. And the first real customer, the first one we can really call that, I think, was a French furniture startup.
Exactly.
They did They did small pieces of tables and shelves and things like that. And they did it with automated manufacturing. And so they wanted a configurator where you could, everyone could just adjust their furniture to their needs, then produce the data they needed to produce it, and then, cut it out of wood and deliver it.
Fun story is that in the end, it was really our first client who we found because they were using Grasshopper, right? I'm pretty sure they were using Grasshopper. And showed us via an announcement. One story was that we ended up implementing something for them that was against our principles in the end. But we did it because it was our first customer. Because we run Grasshopper in the cloud, so if in a 3D configurator powered by ShapeDiver you change a parameter, naturally there is some time it takes for the visualization to update, right? But for this specific customer, we ended up implementing something that did the update directly in the browser, because they they just asked us whether we can do it, and so we did it, and we needed the money at the time, so that's how we ended up doing something that was actually against our principles.
So it was only very, very partly relying on Grasshopper, but it was a client, and when you started your company, you're happy that someone wants what you're selling. So.
But I feel it's something that it's not wrong. On the contrary, it's a must. At the beginning, you need to be flexible, because if you don't get clients, how do you know if you're going to be successful, or if your product, there's going to be a market fit for your product? So I don't think it's the wrong the wrong thing that you
definitely wasn't wrong.
Yeah. No. Well, it proves.
I think it's in the natural progression of companies like ours. You start somewhere in the beginning, you have to find the money where it comes, and you cannot be really picky, right? And then over time, you find really what it is that you want to do, and you get hopefully in a position where you can get focused in the clients that you take and the projects that you actually take on. And of course, especially in the beginning, when you start a SaaS company, there's very little income. If you start from zero and you're collecting your first customers, you can't really, put the food on the table with just the software as a service income. So projects were a really important part of what we did back then.
Yeah. And after, you make it sound so easy, but I bet that after working a whole year with the whole ambiguity of just starting one thing, that the idea is great, but you never know if you're going to be successful until you are, right? So I bet that after a year, you just want to sell. You just want to get a first client. And it's hard at the beginning. It's hard, for sure.
It is hard, yeah. I remember us sitting in a lot of workshops thinking about how we're going to sell this thing now.
Yeah. And how we're going to explain it, right?
We're going to explain it, yeah.
So that was over the first couple of years of selling this, there was a lot of pivot, because in the first couple of years, we focused on product configurators. That was not intentional, but we've just found that that's where the money is. That's where we really provided value, because we could build 3D configurators based on parametric 3D models. So they were much, much more flexible than what the competition did. Right?
Yeah.
Because in the e-commerce space, if you have a typical 3D configurator, you have a couple of options. Maybe it's 10 options, maybe it's 100 options, but they are all predefined, and you can just basically choose from them. And we had something that really created a unique product for whoever was using the thing. So that was where we found an avenue to actually advertise this and sell it. And so then obviously you try to start to do workshops and figure out, okay, how do I sell an e-commerce product? How do I sell a configurator? And we pivoted towards becoming a configurator company for a while.
Yeah.
Which is not something we set out to do, and in the end is not what we've become now, but that was really the first couple of months and years, we're really focused on that. And selling that is completely different than something that is built around communication, around Grasshopper and AEC or anything like that.
No, I bet, but it's like every time you said stuff like that, it's the right way to do stuff. Like and I feel it sounds so obvious. Like I just do the one thing and then I can scale it up, or like it's like Jeff Bezos, right, from Amazon. He started doing that. Like the beginning, it was like it's gonna be the biggest library online. Yeah. And it was not going to be the biggest marketplace. He knew he wanted to change how marketplaces work online. But at the beginning, it was just books. And you need to find the right niche at the beginning, which is not also easy. Like, it's not also easy to at least find one place where you're going to be able to sell this. And moving forward, after you did the configurator, right? And then you decided to do to start selling to the AC, or how was that pivot you mentioned after doing the configuration phase? Let's call it like that.
I mean, just to be like, Alex, you can tell that story better than me, I think. But just wanted to mention, we always had in mind that there's so many different things that people can do with Grasshopper, right? So we always thought, okay, we want to be this platform, and then people do tons of different things with it. It just turns out, as you mentioned, right, in the beginning you need to make money. And so you're really torn in one direction or the other constantly. You find money somewhere. You have to put bread and butter on the table, and so you dragged essentially in that direction. So we started with configurators without having intended at the beginning, and then we found some trade in the other direction, right?
Yeah, in the first 7 years, right, we grew pretty much. The first 5 years, 4 or 5 years, we grew pretty much organically. With one investment by a fourth partner, AEC, which joined us. Actually, our first employee became shareholder. This was actually a really great step to do. At some point, Rhino Compute, or at that point it wasn't Rhino Compute, it was this project called Grasshopper, came out on as part of a hackathon at AEC Tech that's organized by Fortin Tomasetti, and then this developed into a project at Fortin Tomasetti called Swarm. So we were following that development, and I had some contacts to TT from the older consultancy company, so we warmed that up, and that's how we essentially we basically came to the conclusion that merging these two things would make a lot of sense, and for us to move into open AEC as a further market part.
Yeah, so they were basically trying to do Grasshopper in the cloud as well, but really focused on AEC. And as we found out, like a lot of their focus was really on the application and on the workflows that people in AEC use, right? And obviously they have unrivaled competence in that field. They do this every day, and there's the core studio within TT that really builds the application internally. So they knew how to do this. We are not engineers or architects, so that was not our core expertise. But what we really had solved at that point was how to run Grasshopper in the cloud scalably. And on the other hand, we knew how we wanted to continue that effort, but we needed some external money, some kind of investment to hire a few more people to make the thing more professional, because it was basically the stack had built up from the time we had started as the project at first. And so we just were looking for some initial investment to grow the company a bit and invest into the stack. So that came together nicely, right? They had built up Swarm, and they knew exactly what they wanted to do with it in the AEC space. We had this existing business in e-commerce and a stack that worked quite well that we wanted to expand on. So then they decided that they merge Swarm into ShapeDiver and invest into our company. So they took a stake, and then we continued developing the product in collaboration for a while. That's where the AEC market basically came to us, and of course we gained a lot of insight. And in the year following, that was in 2020. The deal should have happened in early 2020, but then obviously something happened, and that delayed things a little bit. So during the pandemic, everything got thrown out of whack a little bit, but we still managed to close that deal in 2020. And then we, for the next year, essentially rebuilt our stack to make it more professional but more scalable on the back end, and integrated lots of these AEC-based tools and workflows.
It's so cool that you were mentioning that you merged with the Swarm project. Hey, I was actually at the hackathon the way they started that.
Cool, yeah.
In New York, yeah. So I was like, I remember that project. Yeah. I go there every year, almost every year. But it's just, for me, it amazed me that me coming from the industry, I used to think that like the best like entrepreneurs or the best founders would be architects or engineers. And I'm not saying you're not really good architects or engineers who are founders of startups, but I'm thinking that it's a double-edged sword, because when you're an architect or engineer, you end up doing projects and you get bias from it, and it's hard to do something, because in the end you want to change the whole industry, and that's not the way of doing it. You need to find an issue. You need to don't care about like what you feel about the industry. And I feel when founders come from outside the industry are not biased because they just want to solve the problem. They find a problem, they solve it, and they're not trying to change the industry. They're just trying to change it step by step, which is what you did. And it makes, for me, so much sense that you took something from the vision of the industry, but applied a commercial vision that came from outside the industry. So now we have another example to always mention of many founders who are coming from outside the industry and are successful. So it's great to hear a story like this. And I'm just curious, what are the next steps in terms of the roadmap for the next, 5 or 10 years for ShapeDiver now?
I mean, we can start a little bit on a shorter horizon. So what we are currently working on and really focusing on is, I mean, that sounds like a platitude now, but essentially making our customers' lives easier. Because you mentioned, right, that lots of architects and designers learn to code and achieve amazing things, right? But something we noticed that people, when they're using ShapeDiver, the typical workflow, I'm not saying it's the only one, but often happens is someone with a really good knowledge of Grasshopper, some expert, discovers ShapeDiver and starts building cool apps and workflows for their colleagues in-house. Mm-hmm. But then typically they want some kind of a user interface, or they want to build a web app. They want to build something that they can then basically send a link to their colleagues and say, you can now use this. And we make this possible with the ShapeDiver platform, but it is, of course, somewhat limited, somewhat opinionated. You upload your file to ShapeDiver and it looks the way it looks, right? It says ShapeDiver, and there's the ShapeDiver logo, and then there's the parameters, and that's just how it looks. There's some variability, but it's a bit limited. So if you really want to build your own app, you need some web development skills, and then you need some JavaScript, and you need to build your own UI. So we found that that's kind of a barrier a little bit, because then these Grasshopper experts either need to know all of these things themselves, or they need to find someone in-house, or if it's supposed to be even more professional, they actually need to find external help and maybe hire, instead of only hiring us maybe or buying our product, they need to hire an external web developer. So what we're concentrating on now is really to make these Grasshopper experts more self-sufficient. So we're trying to build something where you can really build your web app and you build your tool only within Grasshopper. So you design your UI and you design everything that you want to specify about your app directly without leaving Grasshopper. So you can basically upload the file and deploy and just send it to someone. Because we think that reduces the need for our customers to learn additional things and that are not central to what they actually do.
You can think of it a little as a Grasshopper user. You probably know the human UI plugin or heard of that. So you can think of it like a web-enabled version of that.
Well, that's the short term. That's a basically product-based solution. But then in the end, longer term, I think we just want to really grow with the Grasshopper community. The Grasshopper community is growing. I think it's a tool that's gaining in following. It's of course what we really like about it. It's beloved by its users. It's not one of those tools that you have to use because some corporation is forcing you. It's something people really want to do, and so we basically want to follow this community and make their lives easier by providing them the option to use this professionally, right? So we want to be the Grasshopper company. We want to be the companion. If you take up Grasshopper, if you love using it, you shouldn't be constricted to doing stuff locally, doing stuff like tiny little things that are not really serious. As you mentioned in the beginning, it's not like a little game or just a little tool that you build for you and another colleague. We really want you to be able to deploy this professionally and build apps that are used by hundreds or thousands of colleagues or even millions of people in public-facing tools. Because I think that really empowers this community, and that's what we want to do. Yeah.
No, you're basically lowering the bar much more and following a path that is kind of natural, right? Like everything used to be desktop Now it's cloud, and you're helping your users to keep with their knowledge and do this migration, not having to learn like a new system or a new program. It's so cool, and I wish this could happen in the Beam side, like Revit and Dynamo as well, for example, because that's another issue that those folks are having. Like with Rhino, you can now use a product like yours, but with Revit, you're still tied in to local files, and there's nothing you can do nowadays to transform that with an auto platform or something like that into a cloud solution. So it's amazing.
Yeah, it's really interesting how, I mean, we've been following this for, I don't know, more than 10 years, of course. And for many years, people, like at these events, when you go at these AEC events, it's really interesting how long people have been talking about building this one tool that connects everything, like automation, connecting all these tools together, or maybe building the tool that replaces it. And to me, it just looks like every single AEC company you talk to, they have their own workflow, right? They have their own set of tools. No one uses one tool. They all use lots of them, and they all really use them in unique ways and connect them in unique ways. And to me, at least, it looks like this is going to stay like that for the foreseeable future. And so really, I think it just makes a lot of sense to make an effort to build your product in a way that it can easily fit into these workflows, right? That can easily be collected to other things. Yeah. Because when you go to these architects or engineers and you try to pitch them to completely change the way they work, they just laugh at you and they're like, okay, you have 10 minutes. If you haven't convinced me that I'm faster in this project that I'm working right now with the thing that you're proposing, then I don't have any time for you. So that doesn't work. So you really have to find something where you come in and you say, okay, if you just change this little bit here, or you use this tool, you're going to be really more efficient with what you do now. And the only way you can do this is if you tie into the workflow and just make things work together well. And I think what we're doing specifically has a good chance of succeeding there, because when you upload a file to our servers, it becomes its own web application. It has an API, and you can easily tie it into whatever process you're running. You can either a manual process, but also something that runs 24/7, right?
So that's what we are focusing on. In making the product more accessible, making it easy to connect to other services.
Yeah, and then those are the two things that we mentioned, right? One, standalone, making it easier to work. Standalone, build your own apps only on Grasshopper if you don't want to go out. But then also, if you do want to connect it into a larger workflow, then making that easy as well. And that's especially also important outside AEC when it comes to manufacturing workflows, for example, because Grasshopper and Rhino there's a really powerful geometry engine, right? And so if there's manufacturing workflows where some data comes out of, for example, a scanner, we work with companies that do custom shoes where people scan their feet with a 3D scanner, and that's 3 geometric data that comes along. And now we basically, with Grasshopper, we are one part in their pipeline. The geometry flows into Grasshopper and is processed in a certain way, and then different data flows out on the other side that helps to actually manufacture it, but also create documentation for the customer, or visualizations of the shoe and things like that. So they are really the product is a one piece in the puzzle of a fully automated workflow.
Mm-hmm. And let me ask you a hard question. Do you feel that, because there is some small downside on Grasshopper, which is like processing, right? You get to a point when you have a certain amount of like notes and graphs, and that the processing gets slower, and you feel that could be something you can like fix in the future. I don't know, maybe having, instead of just one file, when you get to a certain amount of graphs, you just subdivide it and then you process it in a more efficient way. Or I'm just saying nonsense here, but Do you feel that can also be improved in the future?
So you hit exactly the right spot there, right? This is a pain when working in Grasshopper, right? So in fact, the way we've built our system and certain web applications, 3D configurators that are built on our systems already using that nowadays, is to actually we make it possible to decompose into multiple Grasshopper files. So this is not very accessible yet to our end users, where they can just from Grasshopper do that. But the components that make up ShapeDiver, they actually they support to do that. So, for example, you can in our 3D viewer plug multiple Grasshopper files running at the same time and feeding their data into the same instance of the 3D viewer. So that way, you can imagine that you can use Grasshopper models running on ShapeDiver to build up a further level of graph, like you have it in Grasshopper, to actually work around that kind of issue, right? In order to parallelize the processing, for example.
Like a simple example that we have is we have configurators for pre-made houses, for example. And there's one Grasshopper file that controls basically the building layer. And this layer has as an output the position and size of the windows. And the type of the windows comes from the tool. And then there's a second configurator, a second Grasshopper file that just builds up the window geometry and puts it in. So you don't do everything in one file. They actually collaborate in building up the thing you see. So that, as Alex has said, it's right now you need some coding to connect all these things together. But that's something we're thinking about making more accessible to in the future.
Good. Sorry for the uncomfortable question, but that was marvelous answered. And this I feel this has been amazing, guys. You have been giving me an amazing journey through what you did at ShapeDiver, so thanks for that. But before we wrap this up, can I make you a couple of ping pong questions?
Sure. Yeah.
Okay. I hope you're ready. I promise this is gonna be easy. So, can you tell me the greatest AEC software?
Grasshopper.
If Mathias says Grasshopper, then I see Rhino.
I thought one of you was gonna say ShapeDiver, but it was good.
Well, I mean,
yeah. Just kidding. What do you think is going to be the next big trend in the AEC?
Well, when it comes to what we're concerned with, of course, we see a lot of movement in the direction of automation, prefabricated manufacturing, modular construction. That's where we have contact points. So,
yeah.
But I don't claim to be an expert.
No, it's a good one. If you could collaborate with any person in history, which person would you choose?
Well, for me, I would choose a structural engineer, Peter Rice.
Yeah. That's a good one.
Yeah.
I actually went way back. I would say Leonardo da Vinci. He did so many different crazy things that would be a blast, I think.
That's a good one. What's your favorite building, and have you ever visited?
So, there's lots of things. I go for Centre Pompidou in Paris.
Paris, Pompidou, the museum.
I'm going to go with the Sydney Opera, and yes, I've been there once.
Another good one. And finally, any book that you recommend for other fellow entrepreneurs or people who are working in the industry?
Yeah.
There is no need to be related with the industry. It could be any book that you feel it's a great book.
Hard things.
Yeah, the hard thing about hard things. I would recommend it. It's Ben Horowitz, right?
Yeah.
Yeah, yes. I think so, yeah.
Yeah.
I know it.
Yeah, this was a good one to read at the beginning.
Yeah.
One thing that stays in my mind, I have to admit I did not read all of it, but it's a really good primer. there's a book, when you're not coming from the industry, there's a book called Structures or Why Things Don't Fall Down.
Oh, yeah, I like this.
And that has been, I wouldn't say I need it every day, but it's just a very good introduction into the world of engineering.
It's a book by this famous British engineer. I forgot.
Yeah, it's an embarrassed. I forgot the name as well. But
He also has a second book called A New Science of Applied Materials. I think that's the name. Amazing book. Can I recommend?
Cool. You gave me entrepreneurship books and also technical books. So
Exactly.
we have homework now. Okay, guys, it has been amazing. I really appreciate your time, and I hope our audience is going to do the same. And we hope to hear more about ShapeDiver in the future.
No, thanks. Thank you. Thanks for inviting us.
Thank you.
Yeah. Have a great day.
Same to you. Thank you.
Thank you. Bye-bye.
Okay. Bye-bye.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'll love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.